not be, and then we can go from there, okay? So, take the denominator, set it equal to 0 and solve, because remember, a denominator can never equal 0. Bring the 16 over and make it negative, and there we go. Negative 16, if you put that in for x, makes the denominator become what? 0. So your domain would simply be all real numbers. All real numbers such that x does not equal negative 16. And so that would be the domain, and of course they just put x does not equal 16, which is fine. I really do prefer, though, you learn to write it the right way, which is all real numbers such that x does not equal negative 16. Okay? So x can be any number except negative 16. Alright, let's find the domain. We take the denominator and we set it equal to 0 and solve to find out what x cannot be. Okay? Bring the 4 over and make it a positive 4. Divide both sides by 2, and there we go. When x equals 2, this entire expression here, which is your denominator, equals 0. So, the domain is all real numbers such that x does not equal 2. Because when x equals 2, guys, put a 2 in right here. When x equals 2, you get 0 for the denominator. Remember, the basis for this exercise, numbers 7 through 12, is to remind you your denominator can never be 0. You cannot have a fraction with 0 in the denominator. So we do not want the x value. We do not want it when it makes the denominator become 0. Number 9. Okay, let's find the domain. So we take the denominator. Did I reveal the answer to you? Just to show you that we're right. There we go. Alright. Let's take the denominator, set it equal to 0, and solve. Now this is a quadratic equation. Obviously, you're welcome to solve it by doing this. But it's really a waste of time when you can factor. Factor is so much quicker, in my opinion. We have a trinomial. The exponent here is twice as big as the exponent here. And your lead coefficient is 1. That's pretty easy. What two numbers when multiplied together give you 1? When added together give you 2? Well, a positive 1 times a positive 1 is 1, and 1 plus 1 is 2. So it looks like to me the factorization would be x positive 1 equals 0. So if you take this group, set it equal to 0 and solve, you get this. And same thing for this group. So x cannot equal negative 1 when negative 1 when x is negative 1. You're going to get 0 in the denominator. And if you don't believe me, just simplify this right here and you'll get a 0. You get a positive 1 here, a negative 2 here, a positive 1 here. Add those up and you get 0. So x cannot equal negative 1. Alright? So the domain would be all real numbers such that x does not equal negative 1. And there we go. That's the right way to write it. I'm not sure why they're writing it like this. That's not the domain. That's the antithesis of the domain. Alright, number 10. Okay, let's take the denominator, set it equal to 0, and solve. This one's going to be really easy. My goodness, it's already factored for us. Look at that. Take this group, set it equal to 0, and solve, and you get this. Take this group, set it equal to 0, and solve, you get this. So x is all real numbers such that x does not equal negative 1, positive 8. There is your domain, all real numbers, so that x does not equal negative 1 and negative 8. Number 11. Alright, here we go. We take our denominator, 1 minus x, we set it equal to 0 and solve. Bring the 1 over and make it a negative 1. Don't forget the x is still negative. Now there's two ways to look at this. You can say if negative x equals negative 1, then x equals 1. That's fine. Or you can realize this negative sign is really a negative 1. Divide both sides by a negative 1. A negative divided by a negative is a positive. Either way you get 1. So the answer is all real numbers so that x does not equal 1. And there we go. Alright, moving on to number 12. Let's find the domain. Take your denominator, set it equal to 0 and solve. And here we go. Once again, we have a quadratic equation. You're more than welcome to use the quadratic formula to solve it if you want to. That's up to you. I'm going to factor if I can. Let's see if I can. First of all, I have a power of 2 here and a power of 1 here, so this exponent here is twice as big as this exponent here, so we're good there. Now, what kind of trinomial do I have? I have a lead coefficient of 1. That's the easy kind. What two numbers when multiplied together give me negative 12? When added together give me negative 4. Negative 6, positive 2. Multiply those, negative 12. Combine those, negative 4. So my factorization is x negative 6, x positive 2. Set this group equal to 0 and solve, you'll get this. Set this group equal to 0 and solve, and you'll get this. So those two numbers right there are no good to us. These two numbers here make the entire denominator become 0. If you put 6 in for x, you'll get 0. If you put negative 2 in for x, you'll get out 0 for the denominator. So these two numbers do not work. So the domain of x, or in other words, the domain is what x is allowed to be. You would say all real numbers such that x does not equal 6 or negative 2. And there we go. Guys, we have 4 graphing problems. 1, 2, 3, 4, so not too unrealistic. I try to be very balanced with your graphing. I know they take a while. Let's jump right into these. Okay, now, first of all, if you have a grapher, I'm going to grab my grapher right now. If you don't have one, just sit tight. That's fine, no problem. But if you have a grapher, go ahead and hit your little y equals button in the top left corner. And then for your equation, you must use parentheses. You would type parentheses 2x minus 6 and close the parentheses. You must use parentheses. Now hit divided by, and this will pop up. Then you must use parentheses again. You're telling the computer that the entire numerator is this right here, and the entire denominator is this right here. X plus 4, then close the parentheses. Okay, good. Now you can hit graph if you want to. It really doesn't matter to me. The main thing I want you to see is that we have, we can use this now for our table of values, okay? So for those that have a grapher, that's how you would type that in, okay? Now, step 1 is find your horizontal and vertical asymptotes. Step 1. So vertical asymptotes are pretty simple. You take the denominator, set it equal to 0 and solve. There you go. There's our vertical asymptote, negative 4. Alright? Now, let's find our horizontal asymptotes, remember. Let's find our degree. Degree of the numerator, 1. Degree of the denominator, 1. Now if the degree is greater up top, I have no horizontal asymptote. If the degree is greater in the bottom, I have a horizontal asymptote. I'm afraid I just said vertical. Let me start over. If your degree is greater in the numerator, you have no horizontal asymptote. If your degree is greater in the denominator, you have a horizontal asymptote at 0. If if the degrees are the same, you take your lead coefficient and you put them on top of each other 2 over 1. So your horizontal asymptote, because my degree is 1 and my degree is 1, because my two degrees are the same, then I put lead coefficient over lead coefficient 2 over 1, which is 2. So I have a vertical asymptote of negative 4. Alright, let's make this a little bigger here. I have a vertical asymptote of negative 4. 1, 2, 3, 4. There's my vertical asymptote. I have a horizontal asymptote of positive 2. Now remember, if there's ever an asymptote that is broken, in other words, the graph passes through it, even though it's not supposed to, that's going to be your horizontal asymptote. Every now and then the horizontal asymptote that rule is broken every now and then, okay? So we'll worry about that when it happens. Now let's go ahead and slide this back down so we can go ahead and get back to our table of values now. And actually I shouldn't have done that. My vertical asymptote is negative 4. So I'm going to try to get about 7 or 8 values up here. I'm going to put negative 4 right in the middle. I'm going to go a little higher, so negative 3, negative 2, negative 1, 0. So I went to the right. Now I'm going to go to the left. So negative 5, negative 6, negative 7, negative 8. Now, for those that have a graph, or for those that don't have a graph, just sit tight for a second. For those that have a graph, let's go ahead and quickly fill in our table of values. Okay, negative 8 is 5.5. Negative 7 is 6.7. Of course, I'm rounding. Negative 6 is 9. Negative 5 is 16. Of course, negative 4 doesn't work. That's your vertical asymptote, so nothing there. Negative 3 is negative 12. Negative 2 is negative 5. Negative 1 is negative 2.7. And 0 is negative 1.5. Now, for those that do not have a grapher, okay, you do not want to do that. For those that do not have a grapher, you're going to have to do this longhand. Now, it's not that bad. It's really not. Put a 0 in for x. I mean, that's easy. Put a 0 in for x. 2 times 0, 0 minus 6 is negative 6. 0 plus 4 is 4. Negative 6 divided by 4. Type that into your calculator. Negative 1.5. Now we put 1 in for. Now we put negative 1 in for x. Put a negative 1 here. 2 times negative 1 is negative 2. Negative 6 all over. Put a negative 1 here. Negative 1 plus 4 is 3. So I get negative 8 over 3. Type that into your calculator. Negative 8 divided by 3, negative 2.7. It's not that bad, guys. Okay, you'll be fine. Negative 2. And plus, I've only given you 4 of these on purpose. Okay, so negative 2 in for x. 2 times negative 2. Put a negative 2 here for x right here. 2 times negative 2 is negative 4, negative 6. Put a negative 2 right here. Negative 2 plus 4 is 2. That's negative 10 over 2. That's negative 5. Negative 5. I'll do it one more and then we'll go on. Let's jump down to 6. Negative 6. So for x right here, I'll put a negative 6. For this x, a negative 6. 2 times negative 6 is negative 12. Negative 6. Negative 6 plus 4 is negative 2. So I get negative 18 over negative 2, which is positive 9. Positive 9. Okay, those won't take too long, and plus I'm really reasonable. For those that don't have a graphing calculator, I'm really reasonable with how much homework I've given you. Okay. All right, here we go. So let's plot these points, and we'll go from there. 0, negative 1.5. That's right here. Negative 1, negative 2.7. Negative 2, negative 5. Negative 3, negative 12. Way down here somewhere. 10, 11, 12, about right here. Okay. Now, I'd like to actually go a little more to the right here and just use my grapher. I'm just kind of curious. I think it's going to look like this, guys. It's going to hit this. Most of them have a curve to them. Like this. It's going to curve. So I'm kind of curious what it does at 1. Negative 0.8. And then at 2, it's negative 0.3. And then at 3, we're at 0. Excuse me. And then at 4, we're at 0.25, and so on and so forth. You can see it's curving. It'll continue to get closer and closer to the horizontal asymptote, but it won't touch it. Okay. And then let's see what else we have here. Negative 5 is 16, so negative 5 is way up here somewhere. Negative 6 is right here. Negative 7 is 6.7, about right here. And negative 8, which is right here, is 5.5. 1, 2, 3, 4, 5. So about 7. Negative 8, about right here. So I think you see the same things happening here. It's going to come down, have a curve. It'll continue to come down more and more, getting closer and closer to the horizontal asymptote. And up here, it's going to shoot straight up really fast. Okay. So there's the graph. Nothing peculiar about that. Nothing difficult. Just pretty standard. All right. Okay, hope that makes sense. Moving on to the next problem. Okay, students, let's go ahead and graph number 33. And on the last problem, I'm not sure why I left off the steps of finding the x and the y-intercepts, but that was definitely poor teaching on my fault, and I apologize. x equals negative 2.5. So there's the vertical asymptote, okay? Now, the horizontal asymptote, my degree in the denominator is 1. There's no degree up here, so I could put x to the 0 power if I wanted to. So I have a 0 degree up top, a first degree in the bottom whenever the denominator is smaller. Whenever the denominator is greater in the bottom or smaller in the top, however you want to say it, we have a horizontal asymptote of 0. So I'm going to go ahead and put a horizontal asymptote at 0. So let's go ahead and get these taken care of real quick here. Vertical asymptote at negative 2.5. So negative 1, 2, negative 2.5 right there. I think it'd be a lot easier. Instead of using dotted lines, I'm going to use solid lines for my asymptotes, but I'm going to use different colors. So from here on out, my asymptotes will be in red. Now you'll have to do dotted, that's fine, but I'm going to use solid different colors, okay? So there we go, there's my vertical asymptote. Now my horizontal asymptote's at 0. So it's going to go like this, and it's going to fall right on top of the x-axis right there, okay? So there would be my horizontal and vertical asymptotes, unless I made a mistake somewhere. Alright, so let's go ahead and get all this taken care of here, if at all possible. And then we'll slide it back down. Alright, there we go. Now next, let's find the x and the y intercepts, okay? So the x and the y intercepts. In order to find the x-intercept, we take the denominator, we take the numerator and set it equal to 0 and solve. Well, there's nothing you can do with 3 equals 0. There's no variable to solve for, so there will be no x-intercept. So no x-intercept. Which, can I say something real quick? That makes sense, doesn't it? Don't we have a horizontal asymptote right here on the x-axis? So how could there be any points on this thing, okay? There can't be. So no x-intercept. Let's go over that again. How do you find the x-intercept? You take the numerator, set it equal to 0 and solve, okay? If you do that, you get 3 equals 0. It's not going to work. Now, how do you find the y-intercept? Well, everywhere there's an x, you put a 0. So 3 over 4 times 0, there's an x, positive 10. Well, 4 times 0 is 0 plus 10 is 10, so 3/10. So I have a y-intercept of 3/10. So on the y-axis, I'm going to have a point at 3/10 or 0.3. So right there, I know there's going to be a point there. Okay, so far so good. We have our asymptotes put on the graph, and we have our x and y intercepts put on the graph. So now we're ready for our table of values. So we have an x-intercept, we have a vertical asymptote at negative 2.5. Negative 2.5, so I'm going to go about 4 numbers to the right of that, and 4 numbers to the left. So negative 2.5, I'm going to go negative 2, negative 1, 0 and 1. So right here in the middle, I'm going to put negative 2.5. That's my vertical asymptote. Going a little higher out of negative 2, negative 1, 0 and 1. Getting a little lower out of negative 3, negative 4, negative 5, negative 6. There's no need to have decimals over here except where the vertical asymptote is. Now, if you've typed this into your graph, or like you should have, and if you've done it correctly, you're going to get these values out, okay? We're going to start with 1 first of all, and actually, I'm going to start with negative 6 first. Negative 6 is negative 0.2. I rounded that, of course, negative 0.2. Negative 5 is negative 0.3. Negative 4 is negative 0.5. And negative 3 is negative 1.5. Negative 2 would be negative 1.5. Negative 1 would be 0.5. 0 is 0.3. We knew that already. Remember, 0 is 3/10 or 0.3. And 0 is, or 1 is 0.2. So let's see what we have here. Okay, here we go. 1 is at 0.2. So right here. And I wonder if that's a mistake. I don't think it is. Let me check and see. No, that's correct. We're good. So 1 is at 0.2. 0 is at 0.3. Negative 1 is at 0.5. And negative 2 is at negative 1.5. So about right here. So I can pretty much see what the graph's going to do, can't you? It's coming up. It's getting closer and closer to the vertical asymptote, but it's not going to touch it. Over here it's getting closer and closer to the horizontal asymptote, but it's never going to touch it. Okay? Now, over here on the other side we have negative 3 is negative 1.5. Negative 4 is negative 0.5. Negative 5 is negative 0.3. Negative 6 is negative 0.2. So it's getting closer and closer to your horizontal asymptote, but it's never going to touch it. And it's getting closer and closer to your vertical asymptote, but it's never going to touch it. Okay? And there we go. We've got our graph. Alright? So that's it, guys. Again, follow the steps. Find your vertical and horizontal asymptotes first, then find your x and y intercepts, then fill in your table of values based on your vertical asymptotes, and you should be fine. Alright, number 36. Here we go. Let's find our vertical and horizontal asymptotes first. For the vertical asymptote, we're going to take our denominator and set it equal to 0 and solve. Bring your 6 over and make it negative 6. Divide both sides by 2 and x equals negative 3. Alright, so there's your vertical asymptote, negative 3. Now your horizontal asymptote, we have none. Whenever your degree in the numerator is greater than the degree in your denominator, you have no horizontal asymptote. So there is no horizontal asymptote. Okay, so with that in mind, let's go ahead and place our vertical asymptote on here, and then we'll continue on. And actually, I messed up on the last problem. I should have made these graphs a different color, like I told you I would, and I apologize for not doing that. Not the end of the world, but still, like I said, I'm going to do my asymptotes in one color and my graphs in a different color, okay? Because the dotted line with the mimeopad is really a pain to do, so that's how I'm going to do the asymptotes from now on, different colors. So my vertical asymptote is going to be at negative 3. So here's my vertical asymptote, and we'll slide this over right here. There we go, vertical asymptote, okay? No horizontal asymptote. So we're good there. Now, let's find the x and y intercepts. In order to find the x-intercept, we're going to take the numerator and set it equal to 0 and solve. Divide both sides by negative 3. Take the square root of both sides, and we get 0. So the x-intercept is 0. Now let's find the y-intercept, okay? Here's how we find the y-intercept. Everywhere there's an x, we put a 0. So negative 3, 0 squared, 2, 0, positive 6. So up here I have 0 squared is 0 times negative 3 is 0. Down here I have 2 times 0 is 0 plus 6 is 6. 0 over 6 is 0, so same thing. There's my x-intercept. Now, by the way, some of you might have been thinking, Mr. Earhart, we did not have to do that work right there. We did not have to find the x-intercept because once we found the y-intercept, because once we found the x-intercept was 0, then we know the y-intercept is also 0. That's true, but sometimes there can be more than one y-intercept. That's the only thing you gotta be careful of, okay? Sometimes you can have more than one y-intercept, and so that's kind of why I wanted to check that. All right, okay, moving on. Now we're ready to do our table of values here. So here we go. We have one vertical asymptote, so I'll put about 9 ordered pairs up here, I guess. Right in the middle, I'm going to put -3, which is my vertical asymptote. Then I'll go a little higher, -2, -1, 0, 1, and then go down -4, -5, -6, and -7. Now, students, I want to stress to you again that just because you don't have a graphing calculator does not mean that I'm being a little lazy and not taking time to do all these for you. That's work you can do on your own, then put your numbers in, okay? In Algebra 2, I would not take time and put all these numbers in for you. Not the level you're at. You should be able to do that on your own, then check your work. Now, if you're typing this into your grapher, don't forget, excuse me for yawning, parentheses around the numerator, then hit divide, and then parentheses around the denominator. That's very important too. Now, to be honest with you, for the numerator here, you would really not need a parentheses because it's one term. But still, just to be safe, I am telling you guys to always put parentheses around your numerator and denominator. Alright, here we go. Now, let's get our y values out. When you put -7 in, you get 18.4. When you put -6 in, you get 18. When you put -5 into this equation, you get 20. You get 18.75. When you put -4 in, and I think I've made a mistake here, guys, hold on. -7 is 18.4, -6 is 18, -5 is -18, or is 18.75? -4 is 24, there we go. -3 is your vertical asymptote. -2 is -6. -1 is -0.75. 0 would give you out 0, of course we know that already, 0, 0. And then 1 gives you out -0.4. I've rounded all these to one decimal place, so here we go. 1 is -0.4. Then we have 0, 0 right here, and then -1 is -0.75, and then -2 is -6. So way down to about here. So let's look. I'm going to go a little further to the right to see what's going on here. Could it be a parabola? Possibly. I actually know there's a slant asymptote going on, and it's not going to look like a parabola. It's probably going to look like this, to where it hits here and starts going like that. But let's just check to make sure. Okay, so I'm going to go a little further to the right here. I'm going to see what +2 gives me. +2 is -1.2. About right there. +3 is -2.25. So -2.25. Yeah, it's kind of spreading out. It's not going up and doing this. It's not going to be a parabola, okay? It's going to go up, hit right here, and then start coming back down like this, okay? And it'll kind of flatten out like this. That's what it's going to look like. And this will come down, getting closer and closer to the horizontal, to the vertical asymptote. Now, over here on the left, we have -4 is 24, so it's way up high. -5 is -18, way up high. So we're going to have to get these on here somehow. So I'm going to go ahead and go like this, and see if I can group this together so it slides down easier. And we're going to have to, so don't forget this part of the graph. Now I'm going to slide it down a little bit and get some more tick marks here. Alright, so that's 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Now, let's see what we have here. -4 is way up at 24, so way up here somewhere. -5 is at 18.75, so about right here. -6 is at -18, so about right there. and negative 7 is 18.4, so it starts to go back up again. So negative 7 goes up to about right here. Alright, so it's not going to be a parabola like this. Okay, like that. It's going to be more like, it's going to come down like this, and then shoot more off to the left side like that. Okay, and you can find that out by plotting more points to the left here. Negative 8, negative 9, negative 10, and you'll see that, okay? And this goes up and has an arrow, of course. Alright, now your slant asymptote. Well, we're not getting into that. That's pre-calculus, so I'm not going to worry about that now, but there is a slant asymptote that looks like this. It looks like this. Like that, and that's why this graph is getting closer and closer to that dotted line. This graph here is getting closer and closer to this dotted line. Plus, my graph's not drawn very well because I had to extend it here and get some different, all of my tick marks are not the same distance apart and stuff like that, but, I'm just saying that's why they're kind of going straight like this and straight here. There's a slant asymptote right here, and we get more into that in pre-calculus class. Okay guys, last one. Let's see how we do. Step 1, let's find the vertical and horizontal asymptote. So here we go. And here we go. To find the vertical asymptote, take your denominator, set it equal to 0 and solve. Bring your 9 over, make it a positive 9. Take the square root of both sides, you get positive negative 3. So we have 2 vertical asymptotes, okay? 2 vertical asymptotes, positive and negative 3. Negative 3, positive 3, there's your vertical asymptotes. Now, horizontal asymptote, remember, if your degrees are the same in the numerator as the denominator, you take your top lead coefficient, negative 2, and put it over your bottom lead coefficient, which is 1. Negative 2 over 1 is negative 2. So we have a horizontal asymptote at negative 2. There we go. And there's your horizontal asymptote, or at least close enough. There we go. Now, having done all of that, let's find our x and y intercepts, okay? To find your x-intercept, you take the numerator, set it equal to 0, and solve. Well, you're obviously going to get 0, divide both sides by negative 2. And then take the square root of both sides, and the x-intercept, well, let's see here, yeah, the x-intercept would be, I should have labeled this up here, the x-intercept would be 0. Now, to find the y-intercept, everywhere there's an x, we're going to put a 0, so negative 2, 0 squared, x squared, so 0 squared, negative 9, so 0 squared is 0 times negative 2 is 0, and 0 squared minus 9 is negative 9. So for the y-intercept, we put 0 in everywhere there's an x, we get out 0 over 9, which is 0, which we already know that is 0, so we're good. So we found our vertical asymptotes and our horizontal asymptotes. We found our x and y intercepts. In this case, there's only one right here at 0, 0. So let's go ahead and group that together so we can slide it around if we need to. And now let's do our table of values. Now look guys, we have, we're going to need a really long table of values, okay? Because we've got we have 2 vertical asymptotes. And remember, your vertical asymptotes are kind of what dictates, how many values you're going to put in for x. And that's why I won't give you a lot of these for the 100th time. For those that don't have a graphing calculator, no problem, that's fine. I don't give you a ton of these, and plus you might just want to copy these down off the screen, as long as you know how to substitute the x value in and get out a y value, okay? So here we go. I have one asymptote. Let's start over here to the right. I'm going to start up higher with my positive. So I have a vertical asymptote at positive 3, so I'm going to go over 4. That'll be 4, 5, 6, 7. So I'm going to go 7, 6, 5, 4. 7, 6, 5, 4. Then 3 is my vertical asymptote. So 3, vertical asymptote. And then I want to plot all the points between the two zeros. So 2, 1, 0, negative 1, negative 2. So 2, 1, 1, negative 2. And then my vertical asymptote is negative 3. Negative 3 is the vertical asymptote. Then continue on, negative 4, 5, 6, and 7. Negative 4, negative 5, negative 6, negative 7. Alright, so now let's fill in this table of values. Okay, students, here we go. Now I'm going to start on the bottom here and work my way up. So negative 7, if you substitute negative 7, then you get negative 2.5, rounded of course. And then negative 6 is negative 2.7. Negative 5 is negative 3.1. Negative 4 is negative 4.6. Negative 3, of course, is your vertical asymptote. Negative 2 gives you out 1.6. Negative 1 gives you out 0.25. 0 gives you out 0. And we knew that already. 0, 0, 1 gives you out 0.25. 2 gives you out 1.6. Then you have your vertical asymptote. 4 would give you out negative 4.6. 5 would give you out negative 3.1. 6 would be negative 2.7. And then number 7, negative 2.5. So let's see if we can't graph this. Okay, here we go. 7 is negative 2.5, so 7, negative 2.5. 6 is negative 2.7. 5 is negative 3. 1, 2, 3.1. 4 is negative 4.6. So I think we can see what's going on, can't we? It's getting closer and closer to the horizontal asymptote, like this. And it's coming down and getting closer and closer to the vertical asymptote. These asymptotes really help you see what's going on with the graph. They really do. Okay, now we came to our vertical asymptote. We've plotted these points. Then we have our vertical asymptote. Now let's plot these points. 2 is 1.6. So over 2 up 1.6. 1 is over 0.2. Then we have 0, 0. Negative 1 is 0.25. And negative 2 is 1.6. So it looks like we might have a parabola shape here, okay? A parabola shaped graph here in the middle that's getting closer and closer on the sides to the vertical asymptote, but never touching it. Never coming in contact with it, okay? So there we go, looking pretty good. So I've plotted all these points. Then here's my vertical asymptote. Now I'm at negative 4. So negative 4, negative 4.6. And then negative 5, I go down negative 3.1. And then negative 6 is negative 2.7. Negative 7 is negative 2.5. So I can see what's going on here, just like over here on the right side. The graph is getting closer and closer to the vertical asymptote, getting closer and closer to the horizontal asymptote. And there we go, that's it. So a pretty cool looking graph, okay? The main thing you need to understand about rational functions graphing them is you first find the vertical and horizontal asymptotes. Next you find the x and y intercepts. And then lastly you fill in your table of values. But your table of values is controlled by or dictated by where your vertical asymptotes are at. Okay, guys, and then of course plot the points and sketch the graph. Guys, I hope this video has been a help to you. If you have any questions at all, don't hesitate to contact me.